Hi, my name's Dave Lannom with Monroe Training, and welcome to today's segment on diagnosing circuit faults. This is part four, the short to power. Let's go through our agenda real quick. We're going to talk again about why short to power. And remember, common sense is your best tool when it comes to electrical diagnosis. We'll go through how to diagnose a short to power. We'll do a brief demonstration, and then we'll summarize. Now, keep in mind, there's other prerequisite training you should have already done. Schematic symbols, basic electricity, relays, digital voltmeters, circuit construction, the electrical laws, open circuits, and a short to ground. We'll review some of that material, but we will breeze through it relatively quickly because we've covered it in the previous modules. And again, why circuit faults? No doubt. With the proliferation of electronics in vehicles today, we absolutely positively have to be sure we never have to send a guest to our competitor for repair. And when we understand the basics, it makes any testing basic. By understanding testing to the four faults, we can quickly and accurately provide a confident diagnosis to our guest. And remember, a confident, accurate diagnosis builds the guest's confidence. That results in the referral of friends, family, and coworkers. So we talked about short circuits as it related to a short to ground, but now let's talk about the short to power. And by definition, it's simply an unintentional routing of power to power. The symptoms are frequently when one circuit's turned on, two circuits begin to operate. If the second circuit exceeds current rating of the circuit protection, it can blow a fuse. So don't confuse this with a short to ground. And we have to remember the wires that were left undisturbed seldomly lose their insulation. Outside forces moving, puncturing wires, excessive current melting wires, or excessive corrosion. Shorting insulation are things you need to be looking for. And we discussed it before. We're going to look. We're going to look where there's motion. We're going to look where there's things rubbing against it. We're going to look where there's a high potential for corrosion. And again, the tools that we're going to use, we're going to need to be using our digital voltmeter. We'll do that in some cases in voltage, in most cases with resistance. And remember, across the short, we're going to have continuity or that zero or close to zero ohms. But when we get out of limits, the OL, that means we don't have a complete path. So let's go back to the schematics. Remember, we talked about component locations, looking up the harness routing, as well as connector identification and terminal identification. We're not going to do that again today. So let's get right into it. Let's talk about how we could diagnose a short to power. But first, let's take a look at a complaint that a guest might have. And, that'd be very simple. Like all electronic problems, you have to think about not only how the electricity flows, but where does the electricity flow? In most cases, to see both circuits operating with only one control actuated, the fault must be between the load and the switch power. If one circuit operates when it should not, regardless of switch position, the short is between unswitched power in the first circuit and the switch power feed to the load in the second circuit. This could also be a short before the switch to a point in the circuit after the switch. And I'll explain that soon. So keep in mind, the most likely cause is where vibration or other external forces have exposed a conductor. With so many components today operating on the CAN system, focus on the secondary side of the relay. Let's see what we're talking about and do a quick case study. We're going to take a 2018 Nissan Altima. And the guest complaint is simply that the horn sounds continually anytime they turn the high beam on. The horn appears to operate normally with the parking lights only, and the horn operates normally with the low beams on. And the horn operates normally with no lights on. But the one thing that we do notice is when the horn is operating normally, when we honk the horn, the high beams also come on. So where does that share to power have to be? Let's look deeper into both of the schematics. As we take a close look at both of the schematics, what do we find? We see, okay, we've got the full view of the headlamps. We had the full view of the horn relay, and we can pretty much at this point rule out the integrated power module, because the horn relay sits outside of that, independent of the intelligent power module. And the only feed there is to the low current coil. Now, when we look at that really, really closely, what we see is on the low current coil side, that's actually a ground on that white wire. Now, every now and then, we have to take a look at, how everything is fed. And if we really were concerned, we could actually unplug the IPDM to see what goes on. But from there, where does this short have to be? How can we identify if the short is on the left beam or the right high beam? And that's really going to be kind of simple, because if we take a look at, you know, two similar high beam lamps, they should draw pretty much to the same current. Those high beam, the high beam feed is coming through fuse number 34 and 35. And if we were actually to take those fuses out and duplicate the symptom, because with our ammeter in that fuse slot, we'd be able to very, very quickly which side is drawing the most current. Now, by measuring the current flow with the meter, we trace the expected wire using common sense on where the fault should occur. Now, how could I use that common sense? I take a close look, and what I believe is to be true is it's going to have to be between that green wire coming out of the horn relay, which is the power feed on the secondary side of the coil, all the way to the feed on the left front combination lamp. And why did I make that determination? I made that determination to start my process there because I could take a very close look and say, hang on a minute here. That horn, both the high and the low tone horns, are both located right under that left front headlight. So we've confirmed it because we've got excessive current coming through the left headlight fuse. And we're going to click there because we've got a pretty good indication that that horn is located right next to the two. So that's how we'd attack a short to power. But let's take this a little bit more detail and do a demonstration in the shop. So let's summarize. Remember, always keep it simple. Follow the schematic. And did I mention always follow the schematic? Remember, the connector view will keep you on the right track. And if you're ever in doubt, if you're ever really, really challenged, don't hesitate to pick up the phone and call the folks at All Data Technical Support. Roberto or Karen, we do need to insert the phone number for All Data Technical Support here. I hope this module's been helpful for you. Thank you and have a great day.